So first, we'll be talking about AI for biology, the intersection of academic, philanthropy, and industry. Please help us welcome the professor at KTH Royal Institute of Technology and an associate professor at Stanford, Dr. Emma Lundberg.
We're in this very exciting moment when it comes to AI and biology. I've been a part of producing very large biological data sets, running big biological databases. Something that was seeded by this generous gift from the Paramhansa Foundation is to really think about how we can build virtual cell models, representations of cells that can simulate biology. We might be able to develop drugs much, much faster and understand biology and democratize access to these tools. This is where philanthropic organizations can really fill a role. Besides funding research, they can also fund these efforts like should we standardize data formats? How can we provide compute? We believe that the bigger problem to solve is to solve how we can build multi-scale, multimodal models in biology and optimize them jointly across all these scales, from molecules to cells to tissues. And over the past year, we've been able to train models for all those modalities: chemicals, DNA, RNA, proteins, cells, pathology slides, and we plan to release the models for nonprofit use.
Talking about computational medicine, please help us welcome the professor and director of the Center for Computational Medicine right here at UT Austin, Dr. Charlie Taylor. Yes.
Why can't I build a computer model from an image data and actually simulate blood flow in a patient's arteries? How can we use this to actually design surgeries? I decided to start a healthcare company because I was looking at the diagnosis of heart disease and I felt that didn't work very well. Building basically a software-enabled clinical service using a computer simulation of the heart, to basically improve the diagnosis of heart disease. I think if I look at cancer, for instance, I think there's going to be a lot of opportunity to bring digital twin products into medicine, clinical medicine, into patients. It's going to have to get translated through business. Do things you just want to give back. You want to help others.
Talking about impact beyond research, help us welcome the Associate Professor for the Center for Biosystems of Science and Engineering at the Indian Institute of Science. Help us welcome Dr. Mohit Jolly.
One of the other major efforts that we are doing, primarily funded through the Paramhansa Center for Computational Oncology, is to build a community of computational oncologists in India. And the way we are approaching this is we are learning from cancer. There's a large component of non-genetic components into it. The unit of cancer progression is not a single cell, it's a community, it's an ecology, it's an ecosystem. So how can we integrate some of those thoughts into creating, of course, the seed, which is the set of next young cadre of scientists, but also the soil, which is to make the ecosystem more conducive. The goal is to break the silos, to seed local communities. And again, I'm going to draw parallels between cancer, seed micrometastasis so that there can be eventually metastasis, in the sense that there can be eventually growth of these kinds of ideas at different locations, which can contribute overall to the fitness of the ecosystem, which is getting together engineers, physicists, data scientists, biologists, medical doctors, and train them for 3 to 4 weeks on basics of computational oncology. But these silos need to be broken much younger before many of these things get ossified. That is exactly what we are trying to do, to have seed grants, to have joint students, PhD students, postdocs between these institutes, and then generate initial collaboration to then scale up some of these aspects. Understanding that one cell alone or one individual alone is never going to be sufficient to solve the question.
Please help us welcome the Professor of Bioengineering at Stanford University. Help us welcome Dr. Michael Fischbach.
Almost every company fails. The default state of every biotech company is death. And so when you see a biotech company succeed, it's truly an amazing thing. If we were to just stop model development right now and just work with what we have and focus all of our effort and time and mental energy on just doing more with the tools that we already have, the idea is there's so much more we could do. Maybe we would be even more productive than we are right now, because we all know that the capabilities of the current models are vastly underutilized. Resources aren't evenly allocated across the world, but computation is a great equalizer. A lot of people don't want to go on and research because they believe that there are going to be fewer positions available and less money for each position than happened in the past. It's not a great outlook looking forward. If you were trying to predict whether things are going to speed up or slow down in terms of discovery in the future, you should probably ask the people who would make those discoveries, who are the students and the postdocs, and they're all pretty glum. So one of the things I'm most grateful for that gives me most enthusiasm and excitement is sources of funding that are attached to big ideas. I think that especially now when things are especially uncertain, is a great time to get in the game and find a way to supercharge the research enterprise.
All right, thank you. One more hand for this great panel. All right.